Good evening. This video is going to look at the methodology part of your student experiment, which will be the last part you need to consider really before you get into your experiment, but you do need to consider it through your write-up in terms of what you communicate to us. So firstly, I have here the part from the research and planning criterion on your assessment. And I've just got the level 3-4 and the level 5-6 because I figure none of you are aiming for a 1 or a 2. Now the methodology bit here is looking at a couple of things. Firstly, justified modifications to the methodology, and then down here a considered methodology that enables the collection of sufficient relevant data, and then management of risks or ethical environmental issues. Down here the difference, instead of justified we have feasible, and instead of a considered methodology we just have a methodology, and the word sufficient has been removed from the collection of relevant data. In terms of management of risks, considered management versus just management. Now, I'm going to mostly talk about the modifications part, and we'll briefly talk about the risks because that will be a lot more subject specific than the other two. Now, when we have these modifications to the methodology, I'm going to show you the example from the physics paper in terms of what we expect for you to write. So let's scroll down to that here. Now, this is from an example written by QCAA, and you can see here for the method they've got the original method. Well, there is a sentence descriptor about what was done with the original experiment. You don't need to waste your word count telling us what the original method was. The teacher and I, we know what the original method was. We're not marking whether or not you can tell us what the first thing was. We are marking your modifications. So if we go back to those criteria, you get marked for justified modifications and a considered methodology that enables collection of sufficient relevant data. Not did you regurgitate the previous methodology. So don't waste your word limit on it. So we have here a sentence for the original methodology. Now, if you got a if you modified an original experiment from, say, an online resource or something that hasn't actually been done in class, you may want to say, well, the original method did this, give a sentence summary, consult Appendix 1 for further details. If it's in your appendix, it doesn't count for your word limit. That being said, we can't mark your appendix to get credit for you. So putting an original method in your appendix, well, your original method isn't getting marked, but we can certainly see, well, what was that original method? If it's something that has been done in class, keep it to a sentence, maybe 2 sentences if you really got to do something wordy, but don't waste word limit, don't waste time on it. The thing that is relevant here is this heading modifications though. So you can see here that they've told the original method measured the horizontal distance travelled by an object projected at various angles to the horizon. Basically, we shot a ball into the air at different angles. Now, they've got here some modifications. They're saying, alright, well, for this one, we're going to keep it constant at 0 degrees. We're going to do hollow plastic balls of different radii. Mass was added, 7 different surface areas were tested, and each surface area was trialled 5 times. So for example, if the original method only had 3 trials and you say, no, we're going to do it 5 trials, that's a modification. But this person only got given a 3 to 4 for this. They said that there was feasible modifications. Feasible means that, yeah, you could do this. There's nothing there that is unreasonable for a physics student to do. However, it is not justified. So let's go back up to the criterion here. So we're only really looking at this one, feasible modifications compared to justified modifications. This one here about methodology that enables collection of sufficient relevant data, really that's looking at your data. Do you have enough of it? That's how we're going to judge that criterion. So this one little bit about method is only affecting this one sub-criterion for this overall mark. If we have a look here, nothing here is justified about why they did this. Okay? So we say the angle was kept constant at 0 degrees. Why? Because they wanted to just have all the velocity go horizontal. Hollow plastic balls of different radii were used. Why? Why was it hollow? Why did that matter? Did the material matter? Mass was added. Why? Okay? Well, to keep the mass constant, so mass wasn't affected. 7 different surface areas were tested. Why? Okay? So all you got to do is give a bit of justification in order to how this will refine, extend, or redirect the original experiment. You've got to link it back to what you want to achieve. So if we were to look at the purpose of this, the purpose of this one is that they want to look at what does the effect of surface area have on wind resistance, like how much drag an object experiences when it's going through the air. So I'd be going, alright, well 7 different surface areas tested because by having a larger surface area in the ball, we expect to see more drag, as per the rationale, as per an equation up in the rationale. Pardon me. Each surface was trialled 5 times so that we could get an average result, or we could have a more accurate result to remove error. Angle was kept constant. Why didn't we shoot it up in the air? Why did we shoot it horizontally? Again, that would be sort of up to the person. There's a couple of different explanations for it, but to me it was going, well, that way we're not worrying about an extra factor of angle in terms of does this have an effect on it as well. We're just shooting it straight horizontally. Hollow plastic balls of different radii were used. Why? Radius affects surface area. Okay, you've learned about an equation like that in class. Mass was added. Why? We wanted to keep mass constant. So all this person really had to do to get a full mark on this was just make subtle changes to this to explain why did they modify this, to justify the modification. I think we're going to very quickly talk about this other one though, considered management of risks and ethical environmental issues. Now, ethical or environmental issues, not a really big deal for physics. Ethical, definitely probably going to be more a concern for biology. You may be testing involving living organisms, so you may have some ethical concerns that you need to explain here. Environmental issues, you might be looking at, well, how do you dispose of your chemicals at the end of it? That would be an environmental issue. Risks, well, for this one, for example, the risk is that you could get hit in the face with the ball, so don't stand downstream of the projectile launcher when you're shooting the projectile. The risks for this one's pretty straightforward. You may find that there is no real undue risks. Okay, you might be as simple as, okay, we're using some bricks. Be careful not to drop it on your fingers. Done. Chemistry, your risks may be a bit more complicated. Biology, your risks may be more complicated, and ethical considerations as well. So that one, really talk with your teacher about what you expect to do. Okay, so that's all I really need to say about methodology. Remember, if you want the top marks when you talk about the modifications, you must justify your modifications. Okay, easy way to get an extra couple of points there in order to go from the 3, 4 up to the 5, 6 criteria. All right, best of luck.